Hello, this is Brooke Colon from EL6303, and this is homework 7, and this is problem 7 that we're doing, so I'm just going to try and run through this fairly quickly. So we have z of t equals n1 of t cosine omega c t plus theta plus n2 of t sine omega t plus theta, where theta is uniform from 0 to 2 pi, such as uniformly distributed from 0 to 2 pi. N1 of t and N2 of t are WSS, and N1 of t and N2 of t and theta are all independent. So the first one that we're trying to do in this problem is to find E, expected value of z of t. So all of these are pretty straightforward, so I'm just going to run through them. So we have n1 of t and n2 of t are, which then leads to the expected value of n1 of t being n1 of t, and thus n1. And we also say that the expected value of n2 of t is the same principle, and they are both constants. Oh, excuse me. Try and write within the boundary that I'm given, so that would be about here. Alright, so I'll just rewrite that here. That these are constants. And z of t equals the expected value cosine omega c t plus theta, what we're given, and we're just going to run through this. From 0 to 2 pi, since that's what we're given as the domain. Again, from 0 to 2 pi. So we have this here. And so this equals n1 times 0 plus n of 2 times 0. When you run through these integrals, they become 0. Thus, this is equal to 0. So that is A. So let's move on to B. Let me fold this paper so that we can work. And we have B, which is asking us to find our Z of T1 and 2, and if Z of T is WSS. So our Z of T2 equals the expected value of Z T1 times Z T2. Let me again make sure I know how far to go. Alright. So let's write all this out. Expected value. This is going to be really long, so it's going to be coming down the paper. Of N1 T1 cosine of omega C T1 plus theta plus N2 T1 sine of omega C T1 plus theta. We're going to continue this over here. Times N of 1 T2 cosine omega C T2 plus theta plus N2 T2 sine omega C T2 plus theta. And that's essentially what we're working with. So, running through all of this, excuse me, we're going to end up with R of N1 tau times the expected value of cosine omega C T1 plus theta times cosine of omega C T2 plus theta plus, it's a plus sign, one, 2 times expected value of cosine omega T1 plus theta times sine omega C T2 plus theta it's really long, plus, or rather I should just put the plus here so keep consistent. So now let me change this. 1, 2 sine omega C T1 plus theta times cosine omega C T2 plus theta plus N2 of tau times the expected value of sine omega C T1 plus theta times sine omega c T2 plus theta. Now, what this all, I'll write out what the integral becomes fairly quickly. Rather, you can pause the video and look back at what you saw if need be. But I'm just going to write this here. Oh, let me put this on the other side so that you can see this. Plus cosine plus 1 over 2 of 1 over 2 pi 0 to 2 pi, again, sine omega c T1 plus T2 is 2 theta d theta minus sine omega c tau plus 1 over 2 1 2 0 to 2 pi again, sine omega c T1 plus T2 plus 2 theta d theta plus sine omega c tau minus 1 over 2 r into tau 1 over 2 pi 0 cosine omega c times T1 plus T2 plus 2 theta d theta minus cosine omega c tau. So this is what everything is written out. Again, you can rewind if necessary. I'm going to hurry this along. And this is just all equal to 1 over 2 r n 1 of tau plus r n 2 of tau cosine of omega c tau, which is equal to r c of, tau. And for the last part, we have c, which is to, find rz of 0 if z of t is WSS, which it is, and it is equal to 1 over 2 plus N2. Oh, excuse me. Oh, I did put that there. All right. Excuse me if that's hard to see.